No, I don't think so. I think we're going to move to some more commands that look at kind of general hardware attached to the machine. So this is my box, and here we go. We can do something like LSHW, that's list hardware. I'm going to pipe that to less because it's a big list. And what it does is it probes your machine and looks for all the different components of hardware that it can detect and recognizes by the kernel. Now, this is a virtual machine instance running in Google platform. So you can see that like the description of the computer is a GCE system, and the motherboard is a GCE system. And you'll find out that a lot of virtualization solutions do this. I bet if Nate did this on his machine, he'd see QEMU stuff because that's the virtualization solution that is used by default by KVM. But VMware will do this, VirtualBox will do this. And so it's really handy if you are in a virtualized instance. If you actually want to see what's providing your virtual infrastructure, looking at some of the vendor settings in something like this or another utility I'll show you in just a second. So it
And
also
this was
break
one that I learned about planning this show because I hadn't used LSHW before. This is nice that it kind of groups everything all here for you.
yeah, and there's another one that I use that's older that personally I prefer, but this is a redux of that utility. So like it goes through and shows you your CPUs that are attached and all the CPU flags that are on it and the different memory things that you've got. So if you are on a server system where there's like actual memory modules, it'll go through and tell you like the size of each memory module. And if you are using banked memory, it'll go through and describe like what the banks are configured as. I don't know if people have seen this before, but you may open up a server chassis and not all the memory modules are populated, but there's two or three, or actually two or four different groups of them. If that's the layout in there, oftentimes they're banked, which means that you want to add pairs to each collection of memory modules. And it does things like buffering between them and caching a little bit, and you get some benefits from the hardware that way. PCI bus, and then it goes through and actually shows you the different devices attached to the PCI bus. We were actually looking at that earlier with LSPCI. So there's my virtual graphics card, looks at my different disks that are out there and their formats, network controllers. So it's going through and classifying some of the devices it has and telling me things like the description and its device name if it exists on the system and so forth. So that's LSHW. I mentioned that I use an older tool that I've developed a preference for, but that's because it's an older tool that I've used for a really long time called DMIDecode, right? And DMIDecode gets data from the BIOS, or actually the kernel reads from the BIOS when it is first unpacked and executed. And so what we're looking at with DMIDecode is that BIOS information or BIOS information. LSHW then takes the same information, just reformats it. So you'll see a lot of the same stuff here. And so things like the BIOS manufacturer. So again, you'll be able to see Dell, HP, Lenovo, GCP, Amazon, VMware. A lot of times for the hardware manufacturers itself, either in the BIOS information or this next section in the system information, you'll get the serial number or service tag ID. So you are working in a data center, you don't want to have to go to the physical computer to read the sticker that's on it when you want to open a support case with your hardware vendor. A lot of times you can get the information you need out of this tool, out of DMIDecode. Chassis information, processors. So here it goes in a little bit more detail and tell me things like the caches that are included in the processor as well as its speed. It goes into the similar description of memory, just like we saw with LSHW, and then each individual device. So this is a single DIMM that's 4 gig that's exposed to it. And yeah, that's pretty much it.
It's a
So
bunch of
that's
info.
D.
There was a quick comment on the word BIOS that you used. Was it Billy, I think, or someone said BIOS? People still use BIOS. Obviously, we moved away from like the old BIOS style hardware machines to UEFI or EFI. However, this still reads those as well, right? It's not like this is a tool that only reads older school BIOS systems, right?
I think the reason that we're seeing it's a BIOS is a catch-all term that talks about like
Yeah,
hardware manufacturer information. So even though the machine may be UEFI thing, it doesn't actually use BIOS boot.
right.
The same metadata is put in there by the manufacturer.
Just for clarity. That's the only reason I brought it up.
DMIDecode also has a couple of options, so you can look at specific subsystems. So you could do a DMIDecode -T processor, and it just shows you the CPU stuff out of DMIDecode. Or we could do a DMIDecode -T system, and it just gives me that like system information, like its serial number or service tag or whatever. And if you wanted to see more categories, if you use it incorrectly, it says, here are the options you can provide to -T to see the specific things attached. Now we're going to take a slight turn and talk more about like kernel-y things. I was Originally I was going to do this a little later, but I think this probably fits in well now. There is another ls command that I like, LSRQ. So just like we saw earlier, you could use lspci. Thanks, Andre, for -K. You could see the kernel driver, the kernel module that goes with it. This also tells you for the interrupts that are on the machine, which ones are assigned and to what device are they assigned. And so we can see things like which interrupt our network interface card is on, or our VGA card, or the USB bus. And so the first column there, the location column, that's the actual IRQ number that is assigned. The total, that's the number of IRQs that have been sent to that number or to that device, right? IRQ is an
Yeah.
interrupt request. When the kernel is like doing stuff like networking, for example, a packet comes into the network interface and the network interface raises an IRQ to the kernel, say, hey, I got some data. You got to pay attention to this thing. And then the kernel will go and read the data off of the network interface controller.
And I remember setting IRQs with jumper pins. That's how old, far back my computing history goes. Now they're all
And,
soft set on hardware, I'm sure.
yes, they are. And the reason I bring it up is that you can actually assign IRQs to be serviced by a specific CPU. So that the
That's
load
handy.
of IRQs is borne by a specific CPU core. But it also can give you a sense of scope. So, like this machine is not very busy because it gets local timer interrupts. That's
Yeah.
every often the kernel needs to check to see if it needs to change the running process from the CPU to something else in the run queue. That's the local timer interrupt. So that's how long my machine has been running essentially in interrupts. But then we can look at like the VirtIO 0 and VirtIO 1. Those are the next two biggest use devices where data is flowing in and out. I would guess that these are disks, if I had to guess. I'm sorry, no, PCI. They're network cards. And then the next one down is DevTTYS0. So there's a serial console. But you will see these numbers get increasingly large, which might indicate problems. So if you're troubleshooting and you think that you're like being killed by network traffic or something, you might be able to see it here in LSRQ. All right. A lot of the tools that we just showed you are gathering data from the kernel. There's also a place where the kernel stores all of its information, right? So if we go out to /proc, there's a whole bunch of files here with stuff about your machine. For example, when I did LSHW and whoops, and we looked at the CPU stuff, right? So here's the description of my CPU and the processor flags and things like that. It was really coming from proc CPU info, right? So there's information about my machine, including processor flags and stuff. But this gives you even more. So, for example, if you look, let me go up one or two things, you can see the physical ID. So, if you have more than one socket, the physical ID tells you which socket this CPU is on. And then there's the core ID, right? Because we have multi-core systems, so each socket can have multiple CPU cores on it. So it'll also tell you the core ID to go with the CPU in that socket. And this is important for things like pinning, process pinning, where you can say these things belong to this CPU, should only be serviced by the CPU. Or you want to make sure that things like if you have jobs that are related to one another and you are pinning them to a CPU, that you pin them to ones on the same either core or the same socket, because the same socket is going to share caches between the cores. And so if they're two related things or two identical processes, just web server daemons, for example, they can get some help from one another by sharing the same cache with one another. So even though they might be running on different cores, if they're running on the same socket, they can get some benefit from sharing the same CPU cache on that socket. Nate, have you ever paid attention to these flags?
I was actually just going to call attention to the flags section because there can be some really useful info in here if you know what you're looking for. Stuff like, does this CPU support virtualization? Is one of those flags. These flags are basically all features of your CPU, and a lot of these map up to the specs you'll find in CPUs throughout the year. Like you see MMX up there. I don't know if you remember when MMX was a big deal like 20 years ago because of multimedia processing. I
Yeah,
think HVM is what I'm thinking of. Hardware virtualization. I think HVM is the thing that I see hypervisor in the list there too.
so it will vary based on the CPU manufacturer. I think AMD uses HVM and or actually it's the SVM. Thanks, Andre. In the
VMX and SVM. Yeah, there we go.
Yeah. VMX is the Intel flag for hardware-based virtualization. Now, neither of those exist on this CPU
Because
because
it's
this
virtual.
CPU, yeah, it's right. And that's actually why this one shows this flag.
There you go.
This is a VM running on a hypervisor. But these different flags indicate the capabilities of your processor. So things like trusted compute flags that are available, right? Can your processor do trusted compute stuff? We talked about the virtualization ones. Can your CPU do virtualization? And then there's a
Right.
bunch of old ones. The MMX one that Nate referenced, that
Yep.
actually came into Intel set in 1997.
Yeah.
Because I,
SSE and SSE2. I remember those two. Those were I can't remember what they were for, but I remember them when they showed up. There was a big deal about SSE. I forget what it was now.
yeah, and then there's some that we don't really even use anymore, like PAE, which is physical
Yeah.
address 32-bit systems to be able to like address more than 32-bit memory addresses.
Are these
We
like
tend
in
to,
order when they were added too? Because it seems like the older ones are all up there at the top.
I don't know. But so I was doing a little
Sure
bit of
feels that
research because last night I actually wanted to make sure that I had my virtualization ones straightened out. And so I found this really
way. Yeah.
nice wiki page that had broken down by vendor like the common ones and then ones that you sometimes see. And it also had like release dates, which is how I know the MMX was 1997,
Yeah.
along with the Intel advertising that we got in the Super Bowl with the guys in the silver suits dancing from the fab.
Yeah. The bunny suits.
That's right. Anyway, so we digress. A lot of this information is also in. Now, this machine has one CPU. So that's why we saw one CPU listed in proc CPU info and why we only saw
Right.
one CPU in DMIDecode and LSHW. If you have 8 or 12 CPUs, there will be 8 or 12 entries in this file or in those tools. All right. The other one I wanted to show was Partitions. So earlier we looked at a couple of utilities to look at like what disk devices are on my machine. And we looked at LSCSI, which showed you SCSI devices. But disk devices may not just be SCSI, right? We talked about how like RAID controllers might be, was it CCISS or something? There are some weird ones that you'll see. Proc partitions will be where the kernel stores all of its recognized disk devices plus the partitions that are resident on them. That's also a place where I don't know if you've ever experienced this, Nate, where you create a partition on disk and you write it out with your disk partitioning utility, but when you try to work with it, you get errors about not being able to find that partition that you just added.
Hmm.
And that's likely because this file has not been updated because the kernel uses it for actually interacting with these devices. So that's where things like part probe actually tells the kernel to refresh its
Yep.
list of recognized disk devices and partitions. And you can see it if you run part probe and there's a new device, it'll actually like be immediately listed in this file if it wasn't there before.
Now, what this doesn't give you is where they're mapped or whether there's an LVM in there, but it gives you like the raw disk data, which is helpful.
and things like size, right? That's what the number of blocks
Yeah.
tells you.
Yeah. Right.
All right, so Nate, I think those were the list of things that I wanted to cover.
Yeah, the last tool I wanted to bring attention to, and I don't have a demo for this because it requires a physical disk that supports the Smart protocol, which is basically like a disk health monitoring protocol. So if you're on a virtual machine like my lab is, Smart Control gives you nothing. But Smart Control, if you have physical disks, can be a useful tool for checking the health of your disks, which is really its core purpose. There may be other uses for it, but if you have physical disks, there is smart control. It's like smart control dash utils or something, I think is the package you'd want to have installed. It's probably there by default if it's a physical machine. And you can use that to monitor the health of your disks. So just keep that in mind if you're on a physical machine.
Yeah, and I will say that if you start noticing smart control messages being thrown into your var log messages, pay attention because they're
Yeah.
probably telling you your disk is dying a slow and terrible death.
Yeah,
Um,
smart is something that's literally on the disk controller. That circuit board that is on your physical hard drive contains like whatever extensions or whatever smart control is talking to. So if it tells you there's a problem with your disk, this isn't a software glitch. It's the disk itself saying, "Hey, look at me."
the ones that are really bad are the seek error messages or the write error messages. A seek error message from smart control is telling you that a request came in to retrieve a block off of that disk and it couldn't find it. That's bad that you're losing data off of your
Yes.
machine. The other one is the write errors. So it received a write request and it tried to write data to a specific part of the disk and that failed because for whatever reason the disk platter was damaged or whatever. It wasn't able to actually persist that piece of data. So now you're
Yeah.
not writing data you need to write. And disk controllers are good. Like they'll try to rewrite that somewhere else as well. But the fact that you're either having data vanish from your seek errors or having
Right.
data not being written is indicative of that disk failing. You'll want to make sure that you have an active backup, and you probably want to start scheduling a maintenance window to replace that disk with something else.
I have lots of horror stories from my sysadmin days that started with seek and write errors.
Ignore them at your peril. That's
Yes,
what
do
I
not
do.
ignore those. Bad idea. Bad things happen if you ignore those.